This is the video for section 1.3. This section is actually really short. It's the idea of what a simple random sample is, so we'll define that, and then we'll talk about how to get a simple random sample. For this section, since it's really just one main thing, I'm going to say that it falls under the supported level of our ESO lens. You should be able to get a simple random sample if you have steps by using some sort of technology. We won't really be looking at using number tables unless that's just something that pops up. But I think I've set most of the homework as ones that should use technology of some sort, or they just tell you what the numbers are, the random numbers. So you should be able to do these things if you've got the steps written out, or you can find the steps. The idea of simple random sampling is to be simple, meaning that we're not doing a lot of extra steps. We just want to randomly select people in a way that basically any group of the number of people we're selecting, so if I were selecting 10 people, I could select any group of 10 people no matter what. So here's our definition. A sample of n subjects is selected in such a way that every possible sample of that same size has the same chance of being chosen. And so we've got a picture here of randomly selecting phone numbers using a computer. So we can also look at, here's another image of simple random sampling. We're selecting it in a way that, so here I've got a sample of 5. I could have done another random sampling. I can draw names out of a hat. That's random, simple random sample. I can use a random number generator. In fact, if you go on your phone right now and just type in random number, Google will most likely, unless you're using a different browser, or excuse me, a different search engine, Google will actually just give you a random number. And you can tell it its parameters. I need a random number between 1 and 50. I need a random number between 1 and 9,587. Whatever, you can get a random number. There are also random number tables. You do not need to worry about those, I don't believe. I think I've gotten rid of any questions that use the random number tables, simply because technology is something that we have easy access to. So that's the idea of a simple random sample. So how can we get a simple random sample? Well, like I said, we could draw names or numbers out of a hat. You could, if you have a group of 50 people, you could number them and then, like I said, use Google or some other random number generator and just come up with numbers until you have the sample size that you want. You could also put everyone's name in a hat. You could have each person, if you only need 2 groups, have each person flip a coin, and the people who get heads are in one group, people who get tails are in another group. That's a probability, but it is also random, since flipping a coin, as long as it's a fair coin, is a random event. There are lots of different ways that we can get a simple random sample. And so usually the most common is going to be a random number generator. We can also use drawing. We can use some sort of probability method. There's one more thing that I want to mention. I'm going to move this up just a bit. All right, the one other thing that I want to talk about when we're dealing with simple random samples is this idea of getting all possible samples of a certain size. And we had an example in the guided notes that hopefully you watched or went through. And it was about Sophie, who had 4 concert tickets, and 6 of her friends wanted to go, and she had to randomly choose 3 of them in order to be fair. And so we're going to do a similar question, except I'm going to say she has 5 friends who want to go. And I'm going to take a sample of 2. She only has 3 tickets. And so maybe this isn't the same concert. Perhaps this is a football game or whatever other thing that you would have tickets to go to. A movie or Comic-Con. Whatever your favorite thing that you would get tickets for when you don't have to stay home because of COVID-19 and all the craziness that we're dealing with. Well, so she's got these 5 friends. So again, a population size I'm changing just because there are 2 Ks, 2 names that start with a K, and I just want to be able to use the first letters. So her friends are Yolanda, Michael, Kevin, Annie, and Larissa. Now she's going to need to pick 2 people. She's got 3 tickets. She needs to take 2 people with her, unless she just wants to give all 3 of them away, which would be silly unless she didn't want to go. But we're going to say she does. So she's going to pick 2 people to go with her, and we want to list all of the different possibilities. So I'm going to start with any possibility for Yolanda to go. So Yolanda and Michael could go, Yolanda and Kevin, Yolanda and Annie, Yolanda and Larissa. Those are the only possible ways that Yolanda can end up going, is if she's paired up with one of the other 4 people. Now, since Yolanda and Michael have already been thought of, listed, I don't need to put Michael with Yolanda, with Michael first. This is not a place where order matters. This is just listing 2 people are going to go. It doesn't matter if I say Yolanda and Michael or if I say Michael and Yolanda. So I'm going to start with Michael. Michael and Kevin can go. Michael and Annie can go. Or Michael and Larissa can go. So notice I do still have 4 different ways that Michael can go to the concert, but I've only added 3 new ways. And that's going to continue to drop. So when I move on to Kevin, well, so Kevin has already been paired with Yolanda. Kevin has already been paired with Michael. So now when we put anything else, Kevin and Annie could go with Sophie, or Kevin and Larissa can go. So once again, I have 4 different possibilities for Kevin, but only 2 new combinations of possible samples of size 2. And then we've got Annie. Annie and Larissa can join Sophia, or Sophie, whatever her name was, Sophie. And now we've still got, so now Annie, 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 and Annie. There are still 4 different ways that Annie can go. And I've already taken care of Larissa as well. So here's Larissa, 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 Larissa. I have all possibilities accounted for. I've exhausted all possible combinations of 2 people going with Sophie onto this event. All right, so here is the same data that you have in example 2 of your guided notes. I'm going to use this for this section and the next section, and I'm going to do it a little bit differently. So in your guided notes, you were going to use StatCrunch to get a sample of 5 clients, while I am going to do 6, a sample of 6, just to be a little different. And I'm also going to use just my phone because that's what I have available right now. And you have, if you went through the guided notes, you saw how to do it with StatCrunch. So I'm going to go to Google and I'm just going to type in random number. And I know you can't see what I'm doing, but That's all. And it brings up a box. It has a min and a max. I'm going to change my max to 30. Leave my min at 1. So I want a random number between 1 and 30. And when I hit generate, the first number I get is 20. So I'm going to circle 20. Well, I'll highlight it. I'm going to hit generate again, and I got 30. Once again, I got 1. Fourth time, got 16. Number 5 is 7. And sample number 6 is 23. Now, I didn't happen to have a number that repeated. It's possible that I would. When you use the TI-84 calculator, you can end up with a repeated number, especially if you don't select the option. Some calculators now have an option that will let you tell that you don't want any repeats. With StatCrunch, I think you've got that option as well, if I'm remembering correctly. Of course, with the Google, I'm just generating numbers, and so it's very possible that I end up seeing the same number, especially as I select more. But in this case, I was able to get 6 randomly chosen companies for my sample.